I just want to mention one more thing, and then we'll wrap up. We'll close for the day. Okay. Classification. So the pocket algorithm. Okay, and in general classification, okay, it's hard to minimize En. Okay, and the pocket algorithm is one attempt. And I mentioned before that the starting point, if you can improve the starting point, then the pocket algorithm might be able to further improve you. And okay, so that's a way to improve the pocket algorithm. Okay, and now we are presented with a very interesting algorithm. The pseudo-inverse one-step algorithm gives us a set of weights. It gives us a set of weights, W ln, where, so this comes from the pseudo-inverse algorithm. Okay, and let's look at the pseudo-inverse algorithm, and it runs no matter what y values you give me. So let's consider a classification problem where the y values happen to be plus or minus 1. Okay, so if the y values happen to be plus or minus 1, i.e. you are in the classification realm, you can still run the regression algorithm and produce a set of weights. So you can still run the pseudo-inverse algorithm and produce, W ln. And what will it accomplish? It will accomplish W ln transpose xi is approximately equal to yi. But if this is true, if the actual values are approximately equal to the yi, well then the sign will typically agree. The sign of these will typically, if the actual value is close to the plus or minus 1, then its sign will also be close to the plus or minus 1. Okay, and so what that means is that the regression weights will usually perform quite well even for the classification task itself. So regression weights are usually quite good at classification. But that leads to a nice idea. Why don't, when you're faced with a classification problem, first run this beautiful, one-step algorithm to get the regression weights. And who cares that the y values are all accidentally plus or minus 1? You still get a set of weights. You can use those weights as the starting weights in the pocket algorithm, which then can further improve, and it'll further improve for classification. Okay? And so we call that regression for classification. So this algorithm we call regression for classification. So the final output is still going to be sine of this. Okay, but you use the linear regression weights as the starting point to run the PLA or the pocket algorithm. And that works quite well in practice. It's very hard to beat. So now, simultaneously today, we have discussed, the way to tolerate, non-separable data with the perceptron and the perceptron learning algorithm, which led to the PLA, which led to pocket, which then led to regression for classification. So start with regression, okay, and then use those weights in the pocket. Okay. We then discuss regression, where the task is to approximate the y values in the data, not just the signs, to approximate the y values in the data. Okay. And then boom, we have this beautiful pseudo-inverse algorithm that exactly minimizes the error. Okay. And with that, we're going to sign off. See you next time.